Okay, now I want to run another example of an ANCOVA with you with covariates that I think will affect the dependent variable more so than in the example we just saw. The database that I need you to have open is called CRT longitudinal 8, 9, 10. CRT longitudinal 8, 9, 10. And again, that's in your K-12 database. Once you have that database, what I'm going to ask you to do, we did early module, we learned to select certain groups or certain schools or certain types of individuals. And that's what I want to do in this case. I want to go up to data and I want to select cases, and I want to do so when the school, I'm going to go to school year 8, which is a little lower. And what I want to do is I want to select school if school 8, year 8, equals what I know is a very low income school, school code is 104, or I want to select the school that is 112, which I know to be a very affluent school. So those are the values in the cells. So if I looked under school in year 108, 104 stands for Backman Elementary, and 112 stands for Bonneville Elementary. Bonneville is very affluent, Backman, Title I school, very high low income rate, high percentage of English learners, and so forth. So what I've done is I've said data, I just want to select those two schools. And if you remember, when we go back and look at the database, and we look at the data, it'll X out all the cases in the left column that represent students that are not in those two schools. So now I'm going to go up to Analyze. I'm going to go to General Linear Model, one variable. My question is, are math scores significantly different between Bonneville and Backman elementary schools? If I just stop there, I'd be running an independent sample t-test, but again, I know these schools serve very different students, so I'm going to say controlling for free and reduced lunch rate, disability, and English proficiency. So I'm going to go over and I'm going to say univariate because I have one dependent variable and it's test scores. So I'm going to just scroll down to year 8 and I'm going to look at math test scores in year 8. That's my dependent variable. My schools in year 8 are my two groups. Remember that I only picked 2 of those schools. I picked school 104, which was Backman Elementary, and 112, which was Bonneville. And now I'm going to look for covariates. So one of them is ALS level which is in here several different ways. So I'm going to scroll down to ALS level in year 8. ALS stands for Alternative Language Services. So basically I'm saying, are there differences in the English proficiency rates of students in this sample? I'm going to scroll down further and I'm going to look for other variables. And I've got a variable called SES group, standing for socioeconomic status. And basically, that's telling me whether a student qualifies for free lunch, reduced lunch, or paid lunch. And then last, I'm going to pull over special education, which tells me does a student have a disability or not. So I know these two schools have differences in students in the percentage of students that have a disability, that are considered English proficient, and that are low income. So I'm going to run over to options, and I'm going to say, did it again, I'm sorry. I put my covariates under random factor instead of covariate, so move them to covariate. And basically I'm asking the question again, in this one particular year, I'm looking at the percentage correct on the end of year math test, and I want to know, are there differences in those math scores between these two schools after controlling for free reduced lunch, English proficiency, and disability/special education. So I'm going to go over to options, and I want to see the means for each school. I want to see my descriptive statistics, and I again want to see my homogeneity test, my Levine's test of homogeneity or equality of variance, which is an assumption I need for an ANCOVA to be valid. So I click continue, OK, and here's my ANCOVA. And I think this will tell us a lot more about the power of an ANCOVA and the importance of it. First of all, I had 376 students at Backman, 289 at Bonneville. Backman, remember, is a very low income school. On average, its students got 76% correct on the Math 8 test in 1 year, and Bonneville students averaged 90% correct. So there's a 14% correct difference in students. And what I don't want to happen is for people to conclude for accountability purposes and other decisions related to schools to say Bonneville's a better school. Because we don't know if it's really a better school. At this point, we know it serves a very different group of students whose characteristics are correlated with lower and higher scores respectively. Here, we violated homogeneity of variance because my Levine's test is less than 0.05. It's very important to not have this violation. But one way the violation won't matter is if you have almost identical in sizes in both your groups. When you have equal in sizes, equal numbers of students, and we're going to act like 376 is close enough to 289, that error, that violation of error variance, of equality of variance, is insignificant with equal group size. And that's one reason it's good to just run all your tests with equal groups, sample that way. So let's conclude these are close enough where this assumption isn't a problem. If you violated, and let's say you had 500 students in one group and 100 in another, you shouldn't even look at your results. This is the first violation that in practice actually will mess up your conclusions. Okay, so then we scroll down to our major test. Remember that everything below that word intercept until you get to your major groups, those things are covariates. So I asked the question, are there differences in math scores between Bonneville and Backman Elementary after controlling for free reduced lunch rates, English proficiency levels, and special education? My three covariates. SES, that's free reduced lunch or socioeconomic status. I look over here, 0.147. Interestingly enough, it's not even a significant covariate. That's very atypical. Usually, income level is a big factor on test scores, but it's not a significant covariate. However, English proficiency definitely is because my significance is less than 0.05, and disability differences in their effects on test scores is also a significant covariate. So 0.147 non-significant covariate, free reduced lunch rates. Significant ALS level, English proficiency, and disability. So we scroll down here and we say, now, are there differences in test scores between those two types of schools after controlling for reduced lunch, English proficiency, and special ed? And the answer is no, there aren't differences in their test scores after we level the playing field for the differences in students they serve. So I'm going to scroll back to the top, and I'm going to say, wait a minute, Bonneville scored, on average, Bonneville students scored 90% correct, and Backman's only scored 76. How can that 14-point difference not be statistically significant? Remember, those are non-adjusted, so this test doesn't compare the non-adjusted test scores. So let's scroll down towards the bottom, following the overall test, and you see what's called estimated marginal means. The A stands for adjusted, which is the same thing as estimated. So after we control from our 3 covariates, now Backman's mean is an 80% correct, and Bonneville's is an 84. Only a 4-point difference instead of a 14-point difference. So much of the test score difference, 10 points of it, were due simply to differences in students on those 3 demographic variables. Note, Backman's non-adjusted mean, note its adjusted mean is 80% correct, its non-adjusted mean is 76. So it went up 4 points when we took into account student background. Also note that Bonneville's non-adjusted mean was 90, and then when we leveled the playing field for student characteristics, it dropped down to 84. So Bonneville's came down as expected because they don't have many students who have these particular characteristics, and then Backman's went up because they have many students with these characteristics, and now you only have a 4-point difference in math score, 4 percentage points, and that's not even statistically significant. So the moral to the story here is when you're comparing 2 groups that are very different, if those groups differ in ways that also affect your dependent variable, you should absolutely run a covariate, or it's not a fair test. And if you don't want to run ANCOVAs, and you're doing things like comparing test scores between schools, group the schools into comparable categories. So you're comparing yourself to benchmark schools. You're comparing yourself to schools that serve students like you. This is critical because of the perception that comes with low test scores before they're adjusted that impact accountability ratings. And when we think at a post-secondary level, obviously the governor has been very outspoken, and it's in budget negotiations right now. Kentucky's moving to an outcomes-based education model. Well, clearly, and we don't know what's in that model yet, but 4-year and 6-year graduation rates and retention rates are obviously going to be part of that model. And if they take schools that serve very different groups of students and they don't adjust for variables like first generation student, Pell eligible, non-traditional, all they're going to conclude is schools that admit higher entry students to begin with, more students who are not first gen, more students who are college ready, for example, they're going to have higher retention rates and they're going to get more money. The rich are going to get richer, and that's what happens without covariates. So hopefully the state will have people that recognize this because it would be obvious to pick out the predicted winners and losers in this state if you just looked at something like retention rates and said we're going to give so much money based off your retention rate and didn't adjust that at any level. So again, ANCOVA's very significant test, and one that I think comes with fairness. And the more covariates that you use, the more you level the playing field. Again, I could have included variables like race. I could have included mobility rate. I could have included parent education level. And if I had done so, one may have looked at these adjusted means and concluded Backman actually has higher test scores than Bonneville. Unfortunately, more often than not, we conclude Bagman's a failing school, we put them under various sanctions, maybe even a state takeover, and it's just a bad use of data.